Hello guys, this is Big Data Guy and welcome to your fourth Spark tutorial. In this tutorial, we are going to talk about UDFs. UDFs are user-defined function in Apache Spark and they help you perform custom operations on data frame that are not supported by inbuilt Spark functions. We are going to look at some of the inbuilt Spark functions in next tutorial, such as extracting year out of a date column or extracting week of the year out of a date column and many more. However, if there does not exist an inbuilt Spark function to do custom operation that you want to do on your data frame, then you need to write UDF. So let's go ahead and see how to write custom UDF in Spark using our stock price data as an example. So what are user-defined function? User-defined function is basically, let's say you want to do custom processing on a column, right? So in this case, we want to remove this dollar sign, right? Or we want to extract the data out of this. And if you want to do some sort of custom processing, then you can write function and ask Spark to pretty much register that function and execute it on a column, right? So for example, I'll give you an example. So, there's a date and we want to parse out the date into the date format, right? So for example, if you look at the stock schema currently, stocks.print schema, you can see that everything is in string format, right? So how do we actually convert the date into date format? And in order to do that, what we're going to do is we're going to write user-defined function. So let's get started. So let's see how can you do that. So what we're going to do is we are just going to first import the UDF from PySpark. So we're going to say import from PySpark.sql. We're going to say import user-defined function, which is UDF. And by the way, this is actually part of the functions library, right? Within that functions module. So you need to write functions. And then let's import some of the native data types in Python as well. So Python has its own data type, right? So it has date, it has float, it has integer, it has string, and so on. Similarly, Spark has its own native data type. And in order to import that, you need to say spark.sql.types import. You can say I want to import date type, right? So now what we are doing is we are actually importing date type, which is a data type in Spark native, right? So let's write our first user defined function, and that is basically going to be date parser. And then we're going to say date parser is equal to UDF. This is what we're going to register, and we're going to say lambda date, right? So this is actually in string format. So what we are basically writing is we are basically writing lambda function where we are saying that given a date, use date time library to extract the date out of the string date, right? So in order to extract the string date, first we'll need to import the datetime library as well. So we are going to import one more library called datetime import datetime. So once we import the datetime library, we can use that. So we are going to be able to say that datetime dot strp time. So this is actually like stripping the time from string format. So given a string, it's going to go and try to strip the datetime object out of that string datetime, right? So currently what we have, the first argument it takes in is the string datetime. So in this case, because you're writing a lambda function, we are going to say that, take in this variable, pass it through this function, right? And the format in which we have represented the datetime is that we have month slash our day and then slash our year, right? So we're going to say slash y. And what this is going to return is it's going to return Spark's native date type, right? This is what this function is going to return. So what we have done is we have registered a user-defined function that will basically, given a string date, it's going to extract the date type out of it, right? So it's going to convert the string date into the datetime object, and then that datetime object will be converted into the date type object, which is the native data type of Spark. And that's what we're going to be using to actually, parse the dates, right? This function, the user-defined function. So how do you use this user-defined function? So the way that this is going to work is that basically when we say that, you know what, go ahead and create me a new column. So we are going to say stocks with column. So we are creating a new column over here, and we're going to say parsed date, and we'll say, okay, go ahead and use this function to actually parse the date, right? So we're going to use date parser, and the column that we're going to pass in is stocks.date, right? And then let's say, show me the first 5 value after executing this function, and it's going to go and show you the first 5 extracted date time value, right? So you can see over here, the date has been extracted into this date type in the Spark, right? Now, the way that this function actually works is that it's going to go and it's going to go and execute, the value by value, and pretty much pretty much create a new column, right? So for example, in this case, it's going to go and first use this value and run this user-defined function. So in this case, the lambda date is going to be 05/31/2023. Is going to go and use this function to strip out a date time object, which will be converted into the date type object of Spark. And that's the value that this column is going to have for this particular row, right? And so on. Then it's going to take the second value, third value, fourth value, and it's going to run this function pretty much in for loop format, right? So it's going to run a for loop, and eventually you're going to have this new column created, right? So once the new column has been created, we want to be, it returns this new data frame. We want to store this data frame, right? So by default, we are not stored it anywhere. So we're just going to store it as stock. And now we have our new data frame with few more columns, right? So if we look at the stocks.show 3, so in this case, we have one extra column. And I can also go and print schema for this data frame. And as soon as you can see that schema has actually, the parse date has the schema date, right? So you can see that we have used the user-defined function to partially not clean, but we have used the user-defined function to change the data type of this column, right? Now, the next step is that we're going to write a custom user-defined function to actually go ahead and extract the dollar values from here, the price in the float data type, right? So let's go ahead and write another user-defined function to actually extract the dollar out of this column and this column and this column and so on, right? So let's go ahead. So we can write a new function over here. Let's say we write a traditional Python function like this, where we can say that, I want to parse numbers, right? Num parser. That's what you're gonna call this function. And then I'm gonna say that given a value, first what we want to check is that it could be an integer or it could be a float, right? So if it's a float, I cannot go and I don't want to go and strip the dollar out of it because the dollar doesn't exist there. If it's only a string type, then I want to go and extract the dollar, right? So let's go ahead and try to do that. So the first thing that we're going to do is we're going to say, okay, go ahead and actually extract the $sign out of there, right? So in order to write that, we're going to say that if is instance, so we are checking whether or not this value is of type string, then we want to go and strip the dollar value out of it. So we're going to say return whatever the value is, value.strip. We are going to go and strip $sign out of it, and then we're going to say that, okay, entire thing should be converted into float, right? Because we want to return the float price of that particular column, right? And then I can say elif is instance. If it's an integer or a floating point, then we don't want to mess around with it, right? So if it's an integer type or it's a floating type, then we don't want to do anything. We just want to say return value as is. Otherwise, we want to return none, right? So we don't know how to pass this thing. So let me quickly show you what this function returns. So I can say that print num parser. And let's say we have a value 5.5. And then similarly, I'm just going to show you what the different values are going to be represented as. I could have $5.5, right? Or I could just have the floating point 5.5 or 5. Or I could have complex number, hypothetically, a data entry error, right? And then I can go and see what for each of these different value, what this function will return. So, okay, we have an error. So it says is instance float. Yeah, there should be actually two arguments and the value, right? And now it would actually work. So now you can see that, if it's a string and it doesn't have a dollar sign, then obviously it's not going to go and strip that, and then it returns 5.5. If it's a dollar sign, then it's going to strip the dollar sign and then convert it into float, so it returns 5.5, and then so on, right? Float and integer are going to be written as is, and the complex number, which it doesn't know how to parse, is just going to go and say that, return none, right? So what we want to do is we want to convert this into a user-defined function that we could use in Spark. How do you do that? It's pretty simple. All we do is we just say UDF, and we write the function name over here, which is the num parser, right? So I can say num parser, and then we also want to provide a return type. So in this case, we're going to say float, float type, float type, right? And then this is going to be our parse number function, right? And I also need to import the float type from the Spark's native data type. So I need to say from PySpark.sql.types import float type, because we are using it, right? And once we do that, we have registered our own user-defined function that we actually written using traditional Python, not using lambda function, but using traditional Python, right? So this is a second way in which you can actually register user-defined function. First way is you can just write a lambda function, and then the second one is you can actually write a proper Python function and you could register it, right? So in this case, we have written a proper Python function and we registered it. So let's go ahead and actually run this on the open, close, last, high, and low column. So let's see how does it fare. So first we are just going to run it on open. So you're going to say stocks with column, and I'm going to say open again. So when the column name is same as the column name that you're trying to manipulate, it's just going to replace that column name. So it's not going to create a new column like we did in this case, the parse date. It's just going to replace the existing column, right? So I'm just going to say open, and I want to use this parse number function, UDF, and I want the stocks.open to actually be parsed, right? So I can just show me the 5 values, and you can see that open is now parsed over here, right? So new column has not been created, the existing column has been updated, and it has been parsed, right? So similarly, I can go and do the same thing for other things, other column names as well. So in this case, I have already seen that with open, so I can say, okay, now store this data frame into stocks, and then let's modify that modified data frame again into this, different ones, right? And by the way, you don't need to do the copy paste. You can just do a chain operation in this. So what is a chain operation? I can actually go ahead and let me actually put this into brackets. So it's going to think that this is entirely one single operation, right? So I can say, okay, I want to modify all these columns, different columns that you see over here, right? So I want to modify the open, I want to modify the close, right? So this is actually going to be the close and last column. So the second way that you could actually refer the columns in Spark is using this as well, right? So this is how I'm going to refer that column, because I cannot use dot notation in that location, right? I want to change the low values using this, and then I also want to go ahead and do the same thing with the high value as well, in the high column as well, right? So I can go ahead and do this high and then store it as stock, right? So as you can see, I can do a chain operation and it would work just fine. So we have executed this chain operation together. And now I can go and say, okay, you know what, stocks dot show, right? And all of a sudden you can see that we have processed all the different values, except we have actually created one new column called close, because we wanted to rename this column, or we wanted to actually not use this column at all, and we want to use close so that we can refer to it easily, right? So instead of updating the existing column, we have actually gone and created a new column over here, which is the close. Otherwise we have actually parsed the numbers from rest of the columns, right? Now, similarly, I'm going to do one more update on the volume, because now if I go ahead and do the print schema, you can see that all the columns have been changed to float with the exception of volume, and we want to be able to go ahead and update the volume. And then eventually we are going to discard the date, the close last, and the close last column, because we are not going to be using that going forward, right? So let's go ahead and quickly write user-defined function where we are just going to say that parse an integer out of this. And again, I'm going to import the native Spark data type in this case. So I'm going to say from PySpark dot SQL dot types import integer type, right? And I'm going to say UDF, and then I'm going to use lambda function. So I'm going to say given a value, convert that into int value, and then the type should be integer type as the return type for this UDF function. So misspelling. So just going to fix that misspelling, and we are good to go, right? So let's go ahead and quickly update the volume column as well, right? So all we need to do is we're going to say stocks is equal to this, and we are actually updating volume column with the parsing integer, right? So this is what we have, and then I can go and actually see how the column has actually changed. So let's say stocks dot show first 5 values, and then you can see the existing column has been updated. So we can see that by looking at the schema. So we can say print schema, and then oops, no argument, and then you can see that volume has been updated to integer. This is float, this is float, float, date, and float, right? And now let's go ahead and actually drop the 2 other column. Now there's 2 ways that you could do this. One is the simple way where you can just select the column and then be done with it, right? Or you could use like the drop operation and pretty much go with that, right? So in this case, I'm just going to use select and create a new data frame and be done with this and not use the drop operation, right? So let's go ahead and do that. So the way that we do that is we can say that cleaned stocks is equal to stocks dot select, and we want to select a bunch of columns. We want to select ticker, we want to select the date, and then we want to select the volume. We want to be able to select the open price, low price, high price, and then the close price, right? And then once we select that, we can actually go and see our cleaned stocks data frame, show 5 of those, and then you can see this is actually parse date, right? And not the date itself. I have actually misspelled it. So I'm going to go ahead and fix it. So now it's a parse date, and now I can go and see. So we have a properly created data frame, and then we can go and use this to analyze, right? So for example, because these are all integer and floating point column, and I want to see the common statistics about all these columns, I can pretty much use a describe function to see what is the average, standard deviation, and things like that for that particular column, right? So in order to do that, I can just say clean stock. So let me just copy paste this name. I can say clean stocks dot describe, and I have 3 different columns that I want to use. So I can say volume, open, low, high, and close, right? So it's going to calculate the common statistics about this, and then I can go and display the statistics. So as you can see, we have about 15,000 rows, right, for all these different columns. Mean is this, right? So this is actually converted into scientific notation. So 5.1, and then E7 is you multiply it by 7 zeros, right? And then whatever the value you get, right? And these ones are 180, 177, 182, 180, and things like that. So this is for all different stock ticker, which doesn't really make sense. In future, we're going to go and analyze for individual stock ticker what the mean price is over the year, over the month, and things like that. But as you can see, if you want to see at overall data set level what the mean, standard deviation, mean, and maximum value is, you can use the describe functionality, right? Okay, so This is a very basic data frame operation that we have seen today using PySpark. And going forward, what we're going to do is we're going to go and perform advanced operation like group by and joins and things like that, and learn the PySpark by doing. And you can find this notebook on my GitHub link that is attached in the description. So go and use that if you want access to this notebook. And please like the video and subscribe. Thank you.